Hi, everybody, and welcome. We start with 17 divided by 10. That's in our numerator, divided by 3. And this is really the same as 3 over 1, which is equal to 17 tenths divided by 3 over 1. And here we can keep, change, flip. Keep, change, flip. Keep the 17 tenths. Change division to multiplication and flip the last fraction. And that gives us 17 divided by 30. Number 2, 3 plus 7/9 divided by 9/3 plus 2. Well, we have 3 plus 7/9 divided by, well, 9/3 is 3 plus 2. Now we need a common denominator in the numerator. And if I add 3 plus 7/9, 3 plus 7/9, common denominator would be 9, which gives me 27/9. 27/9 is 3 plus 7/9. This is equal to 34/9 divided by 5. And again, we can say over 1, which gives me 34/9. Keep, change, flip. And my final answer will be 34 divided by 45. Number 5, 2n plus 2 divided by 4n in our numerator over 6n plus 30 divided by n in our denominator. Same, keep, change, flip. I can do this because I have a fraction over a fraction. We're going to see in a minute when I cannot use keep, change, flip. I can still use keep, change, flip here. Keep, change, flip. Now I want to simplify, which means I have to start factoring. Here I have 2 times n plus 1 divided by 4n times n divided by 6 times n plus 5. 6 is our greatest common factor. Now I can cancel certain things. I can cancel this n. I can cancel anything that is multiplication. I can cancel that n with this n. I can cancel this 2 with this 4, which is the same as dividing both by 2. I get 1 over 2. And let's rewrite it and see what we have. In the numerator, I only have n plus 1 left. In the denominator, I have 2 times 6, which is 12, times n plus 5. And that is as simple as we can make it. Remember, we can't cancel terms. We can only cancel factors. If the denominator had n plus 1 in it, then we could cancel the entire n plus 1 over n plus 1. If the numerator had n plus 5, we could cancel, but we cannot cancel the n's. Really be careful about that. Very common mistake. This is what I mean when I say you cannot keep, change, flip, because we don't have a fraction over a fraction. If we make it into a fraction over a fraction, we can use keep, change, flip. I start with -8 plus 5 divided by 3n divided by -4 plus 5 over 3n. And if I take the numerator and denominator separately, in the numerator, my least common denominator would be 3n. What I'm going to do is multiply 3n over 3n times -8 plus 5 over 3n. In the denominator, same. I have a common denominator of 3n, so I'll multiply by 3n over 3n times -4 plus 5 over 3n. Now I cannot cancel those 5 over 3n's, even though it's tempting, right? Here I get -24n over 3n plus 5 over 3n. I can just make that, I can just combine those two fractions, divided by -4 times 3n is -12n divided by 3n, and the same in the denominator, I can say plus 5. Now I have a fraction over a fraction. I can simplify. First, I'm going to keep, change, flip. Keep the first fraction. Change the division to multiplication and flip the second fraction. I can see now that 3n is going to cancel with 3n, and my answer is going to be -24n plus 5 divided by -12n plus 5. And I cannot factor the numerator, and I can't factor the denominator. And since I can't factor either one, this is my final answer. I can also factor out a negative. If you don't like that negative as the leading term, I can say this is equal to -24n minus 5 divided by -12n minus 5. And a negative over a negative is a positive. This also is an answer. And then we can cancel the plus with the plus, and we get all of this as a positive number. Either way. Number 9, 10 divided by 25s plus 10 divided by 5s squared. That's in the numerator. In the denominator, I have 5 divided by 5 plus 5 divided by s. Now, what I want to do first here is simplify whenever it looks like it's convenient. For example, if I want a least common denominator, then it would not hurt me to divide 10 by 25 and get 2 divided by 5. Now I could do the same thing to the 10 over 5 right here, but I'm not going to because I want that 5 in the denominator. Let's rewrite this. We have 2 over 5s plus 10 over 5s squared. Okay, let's leave that. And here we have, well, 5 divided by 5 is really just 1. plus 5 over s. You can see that simplifying is going to simplify things for us as well, because to get a common denominator for the numerator, we're going to multiply the first term by s over s times 2 over 5s. Here I have 10 over 5s squared. And I'm not going to change that at all because that's perfect. Again, I'm going to multiply the 1 by s over s. And then I have plus 5 over s. And that's in my denominator. Now I'm going to multiply. I have 2s divided by 5s squared. And you have to be really careful with these 5s and these s's here. Plus 10 divided by 5s squared divided by s over s plus 5 over s. Now I have a common denominator in my numerator. I add 2s plus 10 over 5s squared divided by s plus 5 divided by s. Now I have a fraction over a fraction, and I can keep, change, flip. Let's do it. We have 2s plus 10 divided by 5s squared. Change the division multiplication and flip the second fraction. I can actually cancel that one of these s's with this s. That's about it for the moment, which gives me, oh, but I can factor that numerator and make it 2 times s plus 5 divided by 5s times, well, we got rid of that s. That becomes a 1 and s plus 5. Perfect. I can cancel s plus 5 with s plus 5. I didn't cancel a term, I canceled an entire factor. This becomes 2 over 5s. And that's my final answer.